Hello students, welcome to GK's Maths class. In continuation of functions, we are going to do exercise 1.2. Already we have done question number 1 in my previous video, whose link I will be sharing in the description box. And this is a part 6 of the video where we will be continuing from question number 2 from exercise 1.2 from functions. Okay, so let's straight away get inside the problem. I have explained the concept of one-to-one and onto function in my previous video, so you can always refer to that. I'm not going to waste my time in again talking about what is one-to-one and onto. So we straight get inside the problem. The first subdivision, this is a very interesting problem. The first subdivision is f is a function from natural numbers to natural numbers, and it is defined as f of x is equal to x square. F of x is equal to x square. Now I want to know whether this is one-to-one and onto. We have to check whether this is one-to-one and onto. So clearly, you know, for every x1 comma x2 belongs to natural numbers, if f of x1 equal to f of x2, obviously you have x1 square equal to x2 square. Since x1 and x2 are natural numbers, you just have to take positive square root. So that gives you x1 equal to x2. So here I don't have to do x1 equal to plus or minus x2 because we are dealing with natural numbers. This implies f from n to n is 1 to 1. Very clear. By the definition of one-to-one function. Now, how do I check whether it is onto or not? For example, I'll take 2 belongs to natural numbers. This is in the codomain. Okay, this is in the codomain. 2 belongs to natural numbers in the codomain. This is natural numbers. This is natural numbers. I'm choosing 2 in the codomain. So what is its pre-image? If f of x is x square, x will be root of y, correct? So root 2 do not belong to natural numbers. See, root 2 is not, 2 will become, actually if it is 2 here, it will go to 4. But 2 will not have a pre-image. 2 will not have a pre-image because the pre-image of 2 under the function f of x is x square is root 2. Root 2 is not a natural number. This implies f is not onto. Why it is not onto? Because every element in natural number do not have a pre-image. Every element in natural number do not have pre-image. Like number 2 don't have a pre-image, number 3 don't have a pre-image, number 5 will not have a pre-image, 6 will not have pre-image. So all, like, you know, only 4, 16, 25, 36 they will have pre-image. But whereas so many other numbers in the codomain will not have pre-image, therefore codomain, which is natural number, will not be equal to range. Okay. So this is first subdivision. That finishes this part. Now let's go to the second question. Second subdivision. What is my second subdivision? The function is the same, but it is from z to z. Integers to integers, defined as f of x equal to x square. Now we have to check whether this is one-to-one and onto. Now what happens? You know very well, minus 1 and 1 belong to integers, right? Clearly minus 1 is not equal to 1. x1 not equal to x2. But if you see f of minus 1 is minus 1 the whole square, which is 1. And what is f of 1? Which is 1 square, that is also 1. This implies f of minus 1 equal to f of 1, which is against our definition. If you have minus 1 not equal to 1, f of minus 1 should not be equal to f of 1. Distinct element should go to distinct images. Here distinct element go to the same image. Therefore f is not 1 to 1. This shows that f is not 1 to 1. Now is it onto is something that you need to verify. Now you know very well minus 4 belongs to integers. This is from the codomain. Okay, it is from the codomain. Now, what is root of minus 4? Because y is x square, so x will be root of y. So root of minus 4 cannot belong to z. So all the negative integers in the codomain will not have a preimage. All the negative integers in the codomain will not have a preimage. This implies codomain not equal to range. You don't have to find range, just give one example, that's it. This implies f is not onto. This is the second part of the question. Now what is the third part of the question? The third part of the question will be f is a function from real numbers to real numbers, defined as f of x is equal to x square. It is defined as f of x is equal to x square. Now I need to check whether this is one to one or not. Okay. Now clearly minus 1 comma 1 belongs to real numbers and minus 1 not equal to 1. So what is f of minus 1? As usual, you know it is 1. And what is f of 1? That is also 1. So clearly f of minus 1 equal to f of 1, just as in the case of an integer. Therefore f is not 1 to 1. F is not 1 to 1. Same explanation. Now is it onto? That's again we have to check. So clearly minus 4 belongs to z. You can take the same example. Minus 4 here belongs to real numbers. That is in the codomain. And clearly all the negative real numbers will not have preimage because it will become complex numbers. So root of minus 4 does not belong to R in domain. This implies f is not onto. Why it is not onto? Because codomain is real numbers and definitely range cannot be real numbers. Okay, so this is a very simple way of understanding one to one and onto. See, when it's all about changing the domain and codomain. When the domain and codomain were natural numbers, it was one to one but not onto. Okay, but when it becomes integers and it is real numbers, it is neither one to one nor onto. The property changes. So it is not about f of x is equal to x square alone. It is also about what my domain is and what my codomain is. Okay. Now the fourth subdivision. What is my fourth subdivision? My fourth subdivision will be f is a function from natural numbers to natural numbers, defined as f of x is equal to x cube. F of x is equal to x cube. Now clearly you can see for every x1 comma x2 belongs to natural numbers, if f of x1 equal to f of x2, that is x1 cube equal to x2 cube, and since they are natural numbers, x1 will be equal to x2, or you can say x1 cube minus, if you want to be very specific, a cube minus b cube, which is x1 minus x2 into x1 square plus x1 x2 plus x2 square. Since they are natural numbers, definitely x1 square plus x1 x2 plus x2 square will not be 0, because x1 and x2 belongs to natural numbers. So the only option is x1 equal to x2. This implies f is 1 to 1. See, f of x is equal to x cube. From natural numbers to natural numbers, f is 1 to 1. Now I need to check whether it is onto or not. We need to check whether it is onto or not. Now let us take an example. Say 3 belongs to natural numbers where in the codomain. Now since this is cube, the pre-image will be cube root. 3 power 1 by 3, cube root of 3 cannot be a natural number in the domain. This implies my range cannot be real numbers, cannot be natural numbers, which is equal to the codomain. Therefore, F is not onto. See how nicely it comes? If you take 3 belongs to natural numbers, cube root of 3 is not an integer, is not a natural number. So range cannot be natural number, and natural number is the codomain. So range cannot be equal to the codomain. Therefore, F is not onto. So this is 1 to 1 but not onto. Now what's the fifth subdivision? Let's try the fifth subdivision. F is a function from Z to Z, defined as f of x is equal to x cube. F of x is equal to x cube. Now clearly what happens? For every x1 comma x2 belongs to integers, if f of x1 equal to f of x2, the same logic, okay? You get x1 cube equal to x2 cube. By the same argument you can get x1 equal to x2, x1 equal to x2, and obviously x1 square plus x1 x2 plus x2 square cannot be 0. Okay. So because x1 square is positive, x2 square is positive, and x1 and x2 can be positive or negative, so when you add them up it need not be 0. This implies f is 1 to 1. Correct? Now how do you prove it's onto? The same example. If you take 3 belongs to Z, 3 power 1 by 3 do not belong to Z. This is codomain. This is domain. So same reason, range is not equal to Z, which is the codomain. Therefore, F is not onto. Okay. So for natural numbers to natural numbers it is 1 to 1 but not onto. Similarly for Z to Z also it is 1 to 1 but it is not onto. Okay. Let's go to the next one. Prove that the greatest integer function f from R to R, defined as f of x is equal to greatest integer function of x, is neither 1 to 1 nor onto. Is neither 1 to 1 nor onto. Now let's look at the function. The function is from real numbers to real numbers, and the function is defined as greatest integer function of x. The greatest integer function of x definition is greatest integer less than or equal to x. Very, very simple. You take two integers. I will take two numbers. Say for example, I will take 2.1 and 2.2 belongs to real numbers. 2.1 and 2.2 belongs to real numbers. So this is 2.1 and this is 2.2 belong to real numbers. And you know definitely 2.1 is not equal to 2.2. But what is f of 2.1? Which is greatest integer value of 2.1. Now greatest integer value of 2.1 is very simple. To the left of 2.1, what is the first integer you see? 0 and so on. So to the left of 2.1, the first integer you see is 2. So greatest integer less than or equal to 2.1. So this is 2. So what is f of 2.2? Which is greatest integer function of 2.2. What is greatest integer function of 2.2? To the left of 2.2, what is the first integer you see? The first integer you see is 2. So clearly f of 2.1 is equal to f of 2.2. So 2.1 not equal to 2.2, you have got f of 2.1 is equal to f of 2.2. This violates the definition of 1 to 1. Therefore f is not 1 to 1. F is not 1 to 1. Correct? Now what you will do, you go for onto. Onto. Now for onto, you know it is greatest integer function. So f of x is equal to greatest integer function. My range is always integers. My range is always integers. It will always return only integer values. But my codomain is what? My codomain is set of all real numbers. So range not equal to codomain. Okay. For instance, if you take all real numbers, it will get mapped to only 0, 1, 2, 3, minus 1, minus 2 and so on. But 0.1 do not have a pre-image. 0.2 don't have a pre-image. 0.3 don't have a pre-image. Therefore, range not equal to codomain. This implies f is not onto. F is not onto. Okay. Now, I just want to show you this. Okay, just look at this. This is a GeoGebra. I just want to demonstrate this problem alone. Let me input greatest integer function. The greatest integer function input is GIF, is floor. There's a small error, but it's okay. Floor of x. Look at this. So this is the graph of greatest integer function. Look at this. This is a graph of greatest integer function. And if you see, the graph is drawn only at 0, 1, 2, 3, 4 and so on. And there is no graph in between. There is no graph in between. This shows that the range is only integers. 0, 1, 2, 3, 4. Similarly, minus 1, minus 2, minus 3, minus 4 and so on. They all return integer values. Okay. Since they return only integer values, my codomain is real numbers, but my range is integer. Codomain not equal to range, therefore the function is not onto. Now you understand why my range is all integers, because you can see the graph is only at integer value. It will, greatest integer function always returns only integer values. Okay. And let's go back to our page. Okay. And that's it. This is very clear. Okay. And if you want, you can also see 1 to 1. I'll just show you that also. If you choose 2 points here, if you choose 2 neighboring points, for example, if I choose, I took 2.1 and 2.2. So this is 2.1 and this is 2.2. Both have the same y value. Can you see it? Both have the same y value. Since both have the same y value, it can't be 1 to 1. Okay. Let's continue. The next question is, show that the modulus function f of x is equal to mod x is neither 1 to 1 nor onto. Okay. Now what is the definition of modulus of x? Definition of modulus x is plus x when x is greater than or equal to 0, minus x when x is less than 0. Remember, modulus always returns positive value. Now I have to show it's 1 to 1 or not. So what I will do, I'll choose 2 numbers, minus 1 and 1, which belongs to real numbers in the domain. They belong to the domain. Okay. I choose minus 1 and 1 in the domain here. Now what is f of minus 1? It is modulus of minus 1. You know, modulus of minus 1 is 1. And what is f of 1? F of 1 is modulus of 1, which is also 1. But clearly, f of minus 1 is equal to f of 1, which is against the definition of 1 to 1. Therefore, f is not 1 to 1. F is not 1 to 1. Now, is it on to? Let us see. Now, this is set of all real numbers. This is also set of all real numbers. And this is the function. What is the function? It's mod x. So that means all the positive values and all the negative values, including 0, they all go to all positive numbers. The negative numbers also go to positive numbers. The positive numbers also go to positive numbers. That is why you got a situation where it is not 1 to 1. That means this particular region, you see this particular region, the negative integers is not at all used. This region is not used at all. Okay. So my codomain, my range is all positive real numbers including 0, which is not equal to R, which is the codomain. So codomain not equal to range. This implies f is not onto. This implies f is not onto. You can see the negative numbers in the codomain do not have a preimage. Okay, that is why it is not onto. Just let me show you the graph. Now, it's actually absolute. If you put ABS, you will get modulus. ABS means absolute. It will give you help also. X. Look at the graph. It's modulus of X. Okay. Now, if you want, you can try horizontal line test. I told you, right? Horizontal line test. So, click this. Horizontal line test. Now, if the horizontal line intersects the graph at 2 points, if you want, I can find the point of intersection of this and this. So, you get okay. So, I got 2 points. See, it's minus 2 comma 2 and 2 comma 2. So, for two different values of x, that is 2 and minus 2, I got the same y value. Therefore, it is not 1 to 1. Or in other words, you can say the horizontal line do not intersects the graph at 2 points. Since it intersects the graph at 2 points, it cannot be 1 to 1. Or minus 2 and 2. Or the example which I take, minus 1 and 1, they are different, but they have the same y value, which is 1. Therefore, it is not 1 to 1. Now, for onto, if you see, my graph is only on the positive real numbers. My graph is only on positive real numbers from 0 to infinity. Whereas my codomain is the entire real number. So codomain not equal to range. Codomain is R, codomain is R and range is positive real numbers. Codomain not equal to range. Or the elements on the negative y-axis do not have a preimage. Therefore, the function is not onto. I hope that's clear. Okay. Let's move on to the next question. Show that the signum function, here f is a function from R to R. The signum function is defined as 1 x equal to 0. There's a small error there. 0, when x is greater than 0. 0 when x is equal to 0. Minus 1 when x is less than 0. This is the definition of signum function. Okay. So now, is it 1 to 1 or onto? That's what you have to verify. If you choose 2 not equal to 3 belongs to real numbers in the codomain. In the domain. Both are real numbers. Now what is f of 2? F of 2 is 1. Why? 2 is positive. If x is positive, it returns only 1. What is f of 3? F of 3 is also 1. Why it is 1? Because 3 is positive. So clearly f of 2 equal to f of 3. This implies f is not 1 to 1. F is not 1 to 1. Correct? Now my range is, it takes value only minus 1, 0 and 1. In other words, if I have negative numbers, all the negative numbers go to -1. All the positive real numbers go to +1 and 0 go to 0. So it takes only 1, 0 and -1. So other than -1, 0, 1, no other element in the codomain have pre-image. Pre-image where? In domain. If you want, you write this, or otherwise very simple, range is definitely not equal to codomain. This implies F is not 1 to 1. F is not onto. This shows that F is not onto. Simple definition. Okay. So signum function is very, very powerful, very, very important also. Okay, I can just show you the signum functions slightly. Let's see whether you're able to follow this. Just a second, I made a mistake. Signum function. One second, let me, okay. What is signum function? First of all, I will define y equal to x divided by y divided by abs of absolute x. So I got part of the signum function. You see, when x is greater than 0, I have got y equal to 1. When x is less than 0, I got y equal to -1. But this part is missing, so I will add it. And 0, 0. When x is 0, y is 0. So clearly you can see, if I take 2 points 1 and 2, they have the same y value. 1 not equal to 2, f of 1 equal to f of 2. Therefore it's not 1 to 1. And if you see, the graph takes only 3 values. Your y values are -1, 0 and 1. From the graph itself you can see, it takes value -1, 0 and 1. Since it takes only -1, 0 and 1, no other element on the y-axis have a pre-image. Therefore, the function is not onto. Simple, isn't it? Let's go back to our problem. Okay, question number 6. F is a function from 1 to 3. I will take 1, 2, 3 and it goes to 4, 5, 6, 7. Where 1 go to 4, that is given, 2 go to 5, it's given, 3 go to 6. Perfect. Is the function 1 to 1? Obviously. F is 1 to 1. There's no need to give any explanation because distinct elements go to distinct images. Therefore, this function is 1 to 1. Is it onto? F is not onto. I'm just adding on because my range is 4, 5, 6, which is not equal to the codomain. Or you can say 7 don't have a pre-image. Since 7 don't have a pre-image, it can't be onto. Okay. Now this is our next question. Question number 7 from the Ncert, where f is the first subdivision is f is a function from R to R, defined as f of x is equal to 3 minus 4x. This is well defined because there is no denominator, there is no variable in the denominator, so this is perfectly well defined. It is defined for all values of x. Okay. So now for every x1 comma x2 belongs to real numbers in the domain, okay, if f of x1 equal to f of x2, what do you know? 3 minus 4x1 equal to 3 minus 4x2. So obviously x1 will be equal to x2. This shows that f is 1 to 1. Simple, direct algebraic problem. Now for onto, you have x is equal to, y equal to 3 minus 4x. So what is 4x is equal to 3 minus y. So x is equal to 3 minus y by 4, and this is defined for every y belongs to real numbers because there is no denominator. Suppose if this was 4y, I will say y not equal to 0. But here it is 3 minus y by 4. 4 is a constant. So 3 minus y by 4 is well defined for all values of y. So my range is the entire real number which is equal to the codomain. Therefore f is onto. Therefore f is onto. We'll just have a look at it in GeoGebra also. Now what is the function? Y equal to 3 minus 4x. Look at this graph. This is y equal to 3 minus 4x. Suppose if I draw a horizontal line. Okay. I think something is wrong. I draw y equal to 3 minus 4. 3 minus 4x. Press enter. I got the graph. Now I'll draw the parallel line. Now you can see anywhere you move, okay, it will intersect the graph at only one point. Since it intersects at only one point, this is definitely 1 to 1. Correct? Definitely 1 to 1. Now, is it onto? You see the graph is drawn for all y values. It's drawn for all y values. For every x value, there is a corresponding y value from the graph. So it's very clear that my codomain and my range is set of all real numbers. For every y there is an x, and for every x there is a y. So this function, codomain is R, range is also R, therefore the function is onto. So visually you are able to see it. Okay. Let's go to the next one. Okay. What is the next part of the question? The next part of the question is, I want to know about this. F is a function from real numbers to real numbers, defined as f of x is equal to 1 plus x square. It's nothing great because it is similar to x square but just shifted by 1 unit. So it cannot be 1 to 1. Let's see how. Minus 1 not equal to 1 in R, that is domain. F of minus 1 is 1 plus minus 1 whole square, that is 2. And what is f of 1? 1 plus 1 square, that is also 2. Therefore clearly f of minus 1 equal to f of 1. This implies f is not 1 to 1. F is not 1 to 1. Now how to find the onto? Check whether it is onto or not. Let's see. You have, if I take y equal to 3, okay, y equal to 3, what do you get? 3 equal to 1 plus x square, or y equal to minus 3. Y equal to minus 3. So I get x square equal to minus 4, which is invalid. X square cannot be negative. So minus 3 do not have pre-image. For that matter, no negative numbers will have pre-image. Therefore, codomain is not equal to range. Therefore, f is not onto. Simple, isn't it? F is not onto. You just have a look at it graphically, so that will give you a better understanding of what you are doing. Let us say y equal to, I'll take y equal to x square plus 1, right? Plus 1. This is a graph. So clearly you have the graph. Okay. Just let me pull this down a bit. Now I'll draw horizontal line. Let me draw a horizontal line. So this is a horizontal line. Now clearly you can see when I move this, it intersects the graph at 2 points. Can you see it? Here one point and here's another point. So when the horizontal line intersects the graph at 2 points, it cannot be 1 to 1. And you see the values below 1, 1 to infinity, 1 to minus infinity, they don't have there is no graph. Okay? Or the elements from 1 to minus infinity do not have a pre-image. So my codomain is real numbers, the entire y-axis, but my range is from 1 to infinity. My range is from 1 to infinity. Therefore, range not equal to codomain, therefore the function is not onto. Visually you can see it. Okay? This will give you a better understanding of what you are doing. Okay. Now the next one. F is a function from A to B defined as f of A comma B, A cross B to B cross A is defined as f of A comma B equal to f of B comma A. So here the function is from A cross B to B cross A. And how it is defined as f of A comma B equal to B comma A. So I need to check whether it is bijective or not. So for every x1 comma y1 and x2 comma y2 belongs to A cross B, I am taking 2 points. x1 comma y1 and x2 comma y2 belongs to A cross B. If f of x1 comma y1 is equal to f of x2 comma y2, what is the definition of f of x1 comma y1? It is y1 comma x1 and this is y2 comma x2. This implies y1 equal to y2 and x1 equal to x2, which implies x1 comma y1 is equal to x2 comma y2. This implies f is 1 to 1. Correct? Now for onto, f from A cross B to B cross A. Now for every B comma A belongs to B cross A. Okay. For every B comma A belongs to A cross A, there exists A comma B belongs to A cross B. Why? It's defined like this. F of A comma B is B comma A. So for every B comma A, there must be an A comma B. For a B, you should have an A. For a you should have a B. So there exists A comma B belongs to A cross B. Okay. So for every B comma A, in B cross A, I can find an A comma B where? In A cross B. This implies codomain equal to range. Therefore, f is onto. It's a very simple example. Therefore, f is onto. Okay. Now, let's do the last problem for the day. I want to check whether this function is bijective or not. Okay. F of n1 plus n2 it is. Okay, I made a mistake there. F of n1 plus n2. F is a function from natural numbers to natural numbers defined as f of n equal to n plus 1 by 2. N is odd. N by 2 if n is even. This is the definition. Now I have to check whether it's bijective. If you want to check whether it's bijective, I have to check whether it is 1 to 1 and onto. So this is very, very simple. You choose a number 1 not equal to 2 belongs to natural numbers. This is in the domain. Now what is f of 1? 1 is odd. When 1 is odd, what is the definition? N plus 1 by 2. Here n is 1. So which is 1. What is f of 2? 2 is even. If it is even, it's n by 2. So it is 2 by 2. So clearly f of 1 equal to f of 2. This implies f is not 1 to 1. If it is not 1 to 1, it cannot be bijective. Yes or no? Since it is, if it is bijective, it should be 1 to 1 and onto. Since I proved it is not 1 to 1, Therefore, the function cannot be. Therefore, f is not bijective. Okay, this is the 10th question. Very, very important type of question. Very, very important type of question. Let's see how to go about it. Now, here he says the function is from a to b. So what is a? My a is all real numbers excluding 3. My b is all real numbers excluding 1. I have excluded 3, I have excluded 1. Now this is the function. Now this function to me is well defined because it is defined for all values of x except 3. But I don't have to worry about 3 because 3 is already removed. So this function is well defined in its domain. It's well defined. That's you have to verify first. It's well defined because 3 is at 3 it's a problem, but it's not a problem anymore because my domain is r minus 3. 3 is already removed. The problem is removed, so there is no problem. Okay. Now for every x1 comma x2 belongs to a, if f of x1 equal to f of x2, if f of x1 equal to f of x2, what is f of x1? x1 minus 2 by x1 minus 3. What is f of x2? x2 minus 2 by x2 minus 3. Cross multiply, what do I get? x1 x2 minus 3x1 minus 2x2 plus 6 equal to, cross multiply, x1 x2 minus 2x1 minus 3x2 plus 6. Plus 6 and plus 6 cancel, x1 x2 gets cancelled. Now take this term that side, it becomes x1 because 3x1 minus 2x1 will be x1. Bring this term this side, what do you get? You get x2. This implies f is 1 to 1. F from a to b is 1 to 1. Perfect. Now check whether it is onto. Now for onto, what do? You try to find x in terms of y. How do I find x in terms of y? Cross multiply. xy minus 3y equal to x minus 2. Now take the x together. xy minus x equal to 3y minus 2. I took this 3y that side. So x is common. I get y minus 1 equal to 3y minus 2. So what is x is equal to? 3y minus 2 by y minus 1. Clearly y cannot be 1. This function will not exist for y equal to 1. Nothing to worry because my b, y belongs to b, where b is r minus 1. Okay, where b is r minus 1. So this function is well, even though it's not defined at 1, here in my codomain, that is b, 1 is removed. So this function is defined for all values of y in b. This is defined for all values of y in b. Therefore, my range is b, which is nothing but the codomain. This implies f is onto. Since f is 1 to 1 and onto, it has to be bijective. I'll just show you this on a graph. Just have a look at it. X minus 2 and x minus 3. See this? I need to draw y equal to x, just a bracket, x minus 2 divided by x minus 3. Now look at this graph. It's such a lovely graph. Let me bring it this side. Now clearly you can see this graph is not defined at x is equal to 3. It's an asymptote at x is equal to 3. So that is removed. This graph, both these branches of graph will never intersect x is equal to 3. And similarly, you see at y equal to 1, you will not see the graph. Okay, the graph will not intersect. The graph, I'll just write here, the graph will not intersect at y equal to 1. It will never intersect this. It will never pass through x is equal to 3, and it will never intersect y equal to 1. They are asymptotes. Okay, that is why 3 and 1 is removed from the graph. Since it is removed, I don't have to imagine this red line. Now you can see clearly, if I draw a horizontal line, if I draw a horizontal line, just one second. If I draw a horizontal line, I need to move this for that. If I draw a horizontal line, and if I move it wherever you want, you can move. See this? It has come over here. If I move this, it will intersect the graph at exactly 1 point. Since it intersects at only 1 point, it is 1 to 1. Now for on to, look at the y values. The graph takes all values of y beyond 1, and it takes all values of y below 1. So my range will be all real numbers except 1. I told you 1 is not included, except 1. Therefore, codomain equal to range. Therefore, the function is onto. And this is nothing but a hyperbola. Okay. Let's go back to this. I think we have almost finished it. Maybe I have how many more questions? Okay, 2 more. Let's finish this problem. Y equal to x power 4. Now y equal to x power 4, f is a function from R to R. Very, very simple. Choose -1 not equal to 1. Clearly f of -1 is 1. F of 1 is 1. Therefore, f of -1 equal to f of 1. This implies f is not 1 to 1. Definitely f is not 1 to 1. And you know, x power 4 is always positive. Therefore, my range will be positive into 0 to infinity, which is not equal to R, which is the codomain. Therefore, f is not onto. Or if you want, you can say -4 power 1 by 4. -4 power 1 by 4 is not defined. So -4 don't have a pre-image. Okay. If you have -4, it does not have a pre-image. It does not have a pre-image. Therefore, f is not onto. Okay. So this is, again, we can just visualize this quickly. I'll just plot y equal to y equal to x power 4. It's actually a parabola, y equal to x square, but since it has 4 roots, it will stay at 0 for some time. Okay, that's all. Now if you draw a horizontal line, it intersects the graph at 2 points, therefore it is not 1 to 1, and there is no graph below the negative y-axis, so my range is from 0 to infinity. My range is 0 to infinity, whereas my codomain is all real numbers. Range not equal to codomain, therefore the function is not onto. Or what I explained there is -4 don't have a pre-image. Okay, I hope that's clear. And one last problem, with that we'll finish this. It's a pretty long video. Okay, let's see. Exactly. Show that this function is 1 to 1 and onto. We have to check it whether it is 1 to 1 and onto. It is exactly like what we did today. Okay, the previous problem, r minus 1 and r minus 3. So f is a function. Oh God, f is a function from a to b. I will take my a as r minus 7 by 5 and my b as r minus 3 by 5. Now for every x1 comma x2 belongs to a. Now clearly this function is well defined because it is r 7 by 5 is a problem, but that is removed. If f of x1 equal to f of x2, I get 3x1 plus 4 by 5x1 minus 7 equal to 3x2 plus 4 by 5x2 minus 7. Cross multiply, I get 15x1 x2 minus 21x1 plus 20x2 minus 28 equal to, cross multiply this again, 15x1 x2 plus 20x1 minus 21x2 minus 28. Minus 28 gets cancelled, 15x1 x2 gets cancelled. Clearly x1 equal to x2. This implies f is 1 to 1. Now to check on to, very simple, you try to find x in terms of y. I have y equal to 3x plus 4 divided by 5x minus 7. Cross multiply, 5xy minus 7y equal to 3x plus 4. Take this x term this side. What do you get? 5xy minus 3x is equal to 7y plus 4. So x is common. You get 5y minus 3 equal to 7y plus 4. Therefore, x is equal to 7y plus 4 divided by 5y minus 3. And y cannot be 3 by 5. And definitely my b 3 by 5 is removed. So I don't have to worry. So my y will be all real numbers except 3 by 5. All real numbers except 3 by 5, which is nothing but the codomain. So range equal to codomain. Therefore f is onto. Once you get f is onto, it is bijective. Okay. Just let me just quickly show you this graph also before we stop here. I'll delete. I will, what was the function? I forgot the function. Sorry. Y equal to 3x plus 4 by 5x minus 7. 3x plus 4 by 5x minus 1. Y equal to 3x plus 4 divided by 5x minus 7. Exactly like the previous question. Okay. So this function is not defined at 7 by 5. 7 by 5 is around 1 point something. See, clearly at 1 point something it's not defined. So similarly at 3 by 5. 3 by 5 is like 0.6. See, at 0.6 it's not defined. You see? This is 0.6. It's not defined. And similarly it's not defined here. Correct? Therefore, the domain is all real numbers. It is definitely 1 to 1 because vertical line test works. And my range will be all real numbers except 3 by 5. Except 3 by 5. Okay, therefore it's on. So with that we come to the end of this chapter, end of this particular video. Next class we will do more questions. In fact, we are going to do, today we did all easy questions. That is why I prolonged my video. From next video it will be some difficult questions and functions. Okay, so hope to see you in the next video. Please subscribe to my channel and also click the bell icon to get notifications. Have a wonderful day. See you again in the next class. Thank you.